Hey, what's up everyone? Welcome back to the DIY remote control robot course with the Raspberry Pi Pico W. In this segment, we'll be learning how to control the speed and direction of both of our motors on the robot to ensure everything is moving properly and in the correct directions. A simple program will be written to ensure we have proper motor control, and I'll be going over this program in MicroPython at a high level so you have an understanding of what this program is doing. If you have not already, please be sure to watch the previous segments of this tutorial series where we went over the components and the connections. And also be sure to like, comment, and subscribe to the channel for more robotics courses on this channel. Many more to come in the remainder of the year. Anyways, let's get started by showing you the code and walking you through everything at a high level. Okay, so jumping into our code editor that is Thani, we're going to write a simple MicroPython program. So go ahead and connect to your Pico W as we did in part 1. And you can go ahead and just copy along this code that I'm going to show you at a high level or explain at a high level. Also, this code is available at ShillehTek.com in the blog section. If you're feeling lazy, you can just go ahead and get it and paste it into your Thani. So go to ShillehTek.com on the blog. It is free for you to get that code. So pretty much what this code is doing at a high level, I left a doc string here, so it'll allow you to control the speed and direction of two DC motors using pulse width modulation on the Raspberry Pi Pico W. So pretty much it'll loop, it'll try to move forward, backward, left, and right. And if any of the motors are moving in the wrong direction, you can reverse the polarity of the motor by swapping the connections on the respective DC motor. So pretty much this program is to allow you to make sure that these things are moving properly and in the right direction. So when we write our final program, it will just run seamlessly. In this program, first things first, we just do some imports. Machine to interact with pins on the Raspberry Pi. Then we have time to just manage time and loops and that sort of thing. So we have a bunch of helper functions defined. So this helper function is to allow us to control the speed of the motor. So just know that this function allows us to convert a speed from 0 to 100% into a speed that the motor can understand. And then we set up the B motor. So we just, based on the pin diagram that we had in the previous segments, if you did those same connections, this should be fine. We are setting those pins that we set on the Raspberry Pi. We are setting the ENB frequency, so this is the B motor, and we're setting it to 1 kilohertz, and this reduces audible noise, balances efficiency. You could read more about pulse width modulation frequency on your own. We're not going to get into that too much in this tutorial. And then we just define some helper functions. So helper functions to move B forward. So if we want to move a motor forward, we set IN3 high, IN4 low. Okay, and then we set the speed pretty much with pulse width modulation. And backward is the opposite, and stop both go to low. And A is pretty much the same thing, just different pins that we connected. Once again, if you have the same pin connections as we went over in the previous segments, this should work as well. And we define similar logic where we have these helper functions to move motor A forward, backward, and stop. And then finally, we have this main loop. So what's going to happen in this main loop is the program is going to wait for you to enter a speed from 0 to 100. And 100 being the fastest, 0 being the least. And based on that speed, it'll calculate a signal to send to pulse width modulation for each motor. And then first, it's going to move each motor forward. So if you have the correct setup on your DC motors, both should ideally move forward. Once again, if they do not move forward, you can just swap the alligator jumper clips on the motors themselves, and that'll change the polarity of the motor. And then it's going to wait for 2 seconds. It's going to stop for 1 second, and then it's going to try to move them backward. And then it's going to stop again, and then it's going to try to turn left, stop, turn right, and then stop. And that is the program. So that's really all we are doing, is we are just moving forward, backward, left, right, and just to ensure everything is working as expected. So let's go ahead and run this program. So we can go ahead and, oh, it's not letting me drag this thing up here on the bottom, but we can go ahead and run this. You should be able to see it. So you can see on the bottom here, it's asking me to enter a speed 0 to 100. Let's go ahead and just enter 50%. And you can see on the screen here now, my robot, I'm just going to lift it off the table because there's a cable for my computer and it won't be able to move properly. So I'm holding it. I'm about to click enter. So you see that it's moving forward now. So it looks good. Both wheels are moving forward. Just moved backward. Now it's moving to the left. And then it's moving to the right at 50%. Okay. And then the program stops. We can do 100. You'll see that 100 is going to move a lot faster, really fast. And you'll see that difference. And once again, if there is anything moving in the wrong direction, just go and flip the robot over. And you see with these alligator jumper clips on the bottom, you're just going to go ahead and swap them. So this For example, if this motor is moving in the wrong direction as expected, you could just take these alligator clips and just swap them, and that will reverse the polarity of the motor. So that's all the program is doing. I hope you got it working, and I hope you got it running, and now your motors are moving in the right direction, so congrats. So that sums it up for this segment in the tutorial series. At this point, you should have your motors working and moving properly in the correct direction. So congrats on that and making it up to this point in the tutorial series. Now, meet me in the next segment where we learn about the ultrasonic module and how to program it, prepare it for obstacle avoidance, and learn how to program the LEDs in the module itself. As always, don't forget to like, comment, and subscribe to the channel. Tell your friends and family about the channel as well, and I will see you next time. Thank you for watching.